This video is for those who are going to sit for P3. We are going to have a discussion on the main topics that you really ought to understand as far as P3 is concerned. And if you're new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. And for you to access the PDF of this paper I'm having here, you can be able to use the link in the description so that you can be able to go straight to our Patreon page, whereby you can be able to download the paper. Now, to get started, to see what are the main topics that you really ought to understand, I need to remind you that in P3, you are going to sit for 75 marks, and this paper is going to take you 1 hour 30 minutes. So this is a prediction and a concept paper of the areas that you should not forget looking at as far as the IIL, Edexcel, pure math is concerned. One of the questions that I've brought into perspective in this particular series is the topic of modeling, which is going to involve exponential functions. And here you can see we are given a question, and then you are supposed to answer questions like stating what is the initial value. When you're given question to do with the initial value, you need to understand that initial value is when t is equals to 0. For instance, in this particular question that we are having here is about the heart rate of a horse. Then you are told that the heart rate is given or is modeled by this equation: h is equals to 32 plus 40e negative 0.2t minus 20e negative 0.9t. So you can see now the first question you are being asked, state the initial heart rate. So at that point, if you are asked such a question, remember t is equals to 0. And then when you substitute t is equals to 0 all through anywhere you have t, you're gonna get your value being 52. Then in the long term, the heart rate of the horse approaches L. In the long term, then you are supposed to state the value of L. And you can see now, based on the modeling that we have here, I've said L is going to be basically 32. How do we go about that? How did we get there? Let me just tell you that if we look at the modeling equation that we have here, so what I'm going to say, if at all is approaching a given value, yeah, then it means that as t approaches infinity, according to this modeling that we have here, as t approaches infinity, then this term that we have here will be approaching 0. This term will be approaching 0. Yeah. Also, as t approaches infinity, this term also that we are having at this point here will be approaching 0. So if these two terms are approaching 0, because they are having a negative, so meaning they are going to be smaller and smaller and smaller, and that they are approaching 0, then the entire equation is approaching 32. Yeah, so the entire equation will become 32, because if this approaches to 0 and this approaches to 0, then the equation is going to remain as 32 there. So that's the logic I used there in order for us to have that. Let me take some water so that at least I can be able to continue talking, guys. And if you're new to ProfLearn, guys, just show support by subscribing, to ProfLearn YouTube channel, and all the best in your exams. Okay, without wasting much time, let's look at the third question. Here we are told that the heart rate of the horse reaches a maximum value after t minutes. Find the value of t, giving your answer to 3 decimal places. Maximum value, minimum value, stationary point, turning point. We know that the derivative of the function is equals to 0. So that's why you can see now in this question, since I'm finding the maximum value will occur when dh dt is equals to 0. And how do you differentiate exponential function? When you are differentiating exponential function, your focus will be, of course, if you differentiate 32, which is a constant, that's going to be a 0 because it's a constant. But when you are differentiating exponential function, your focus should be at the top of that exponential function. Which function is there? It's negative 0.2t. So if you differentiate negative 0.2t, you are going to get negative 0.2. Then you take that answer you have gotten, you multiply it with the number in front here. Yeah. So that is why you can see I'm having negative 0.2 times 40, and the function remained the way it was. E is to negative 0.2t. Don't forget. Then to differentiate the second term, you are going also to look at the power, and you differentiating negative 0.90, you are going to get negative 0.9. So meaning that, again, if you bring it down, you're going to multiply it with the number that was in front of the exponent, and ideally it is going to now become positive 18. Now, once you have that particular expression, you are going now to equate everything equals to 0. You are going to equate that expression equals to 0 so that you can be able to go ahead and solve. Now, since we are having negative 8e is negative 0.2t plus 18, so you can see you can be able to take all that we have here on the other side of the equal sign, and then we're going to have expression simplifying to e is to negative 0.9, and then if you are dividing exponentials, then you can be able to subtract the powers. Yeah, basic concepts of dealing with exponents. And that is why now our expression now is going to become e is to negative 0.7t is equals to 0.44. Once you have gotten this, you need now to solve for t, because whenever you have an exponent, then you want to get rid of that exponent, you need to introduce natural log. Introducing natural log both sides, you'll have ln of e is to ln of e is to negative 0.7t, then, and you divide by, it is going to reduce to, let me just show you here, is going to reduce to negative 0.7t, negative 0.7t. Then you divide by negative 0.7, negative 0.7 both sides. That's why now you can see we are going to have this cancelling out, and if you work it out, you will have your final answer given like that. Once you've done that, maybe the other question that can be asked is the question to do with iteration. And under iteration, we are told the heart rate of a horse is 37 BPM after m minutes. Show that m is the solution of this particular equation that we have here. So, how do you show that? We are told the heart rate is that. So, meaning we are going to say 37 is equal to this equation. You are going to take the constant term on one side like that. So if you subtract, you're going to get basically 5. Yeah, and then we bring the negative 20 on this other side, we end up having 5 plus 20 is e is to negative 0.9. Then if we divide by 5 both sides, then we are going to have 1 plus 4, because 20 divided by 5, you get 4, and then we have this one. Now, because we are targeting this, then ideally what we're going to do here is to introduce natural logs so that we can solve for t. Because this equation is having 1 plus 4 e is to 0.9t, and it's actually appearing here, and 8 is appearing here, so that's why we have introduced ln. Then we're going to have negative 0.2t is equals to ln of that. So if you take everything negative 0.2 divided both sides, negative 0.2 1 over negative 0.2. So if you simplify this, you are going to get t is equals to negative 5. But negative 5, when it's brought into the natural log, basically this is going to flip the numbers up down. Yeah, so that's why you can see once we get rid of this negative, meaning that you can raise this function that we have here by negative 1, then you are going to find the reciprocal, which means that we are going to have our equation as expected. Now this is the equation. Then we are told that using the iteration formula, t n plus 1 is equals to 5 ln 8 over 1 plus e raised to power 0.9t n. But now the term t1 is 10. When you find t2, you are going to substitute this into this particular formula where you have t. Yeah, you are going to substitute it here. So which means that if we substitute 10, this becomes negative 0.9 times 10, and that becomes negative 9, which means that if you put in your calculator and you try to work it out, you are going to get 10.3947. Now, in Roman 2, we are supposed to find the value of m, the solution now. So in that case, we keep on substituting the initial answer until you are going to get the terms are not changing. So that is what I did here. I found t3, I substituted t2 that I had gotten here into the iteration formula. Once I got this, again I found t4 by substituting t3 into the formula. I got t5. So I reached a point or a level where even if I did the substitution, there is nothing that was changing, and now that became what? Became the solution, which is 10.3955. And in such kind of question, you have to remember that you have to give the accuracy which the question was expecting you to give. Now looking at question 2 is a question to do with trigonometry, a very common question, a very common concept that you might be asked to answer. Express f of x in the form r cos x minus alpha. F of x was given as cos x plus 2 sin x. So any moment you are going to be given a question like that, guys, what you really have to remember working out is remembering the compound angles. So if you are having r cos alpha minus that, it can be written that as cos x cos alpha plus sin x sin alpha. So if we include the r, now it becomes r cos x cos alpha plus r sin x sin alpha is equal to whatever equation that they are asking us to do. And now, because the two equations are equal, so it will mean that in this equation that we have, then it means that the whole of this part that we are having here must be equals to cos x. You see now, if you equate, you can be able to cancel cos x and cos x out. Then you are going to remain with r cos x is equals to 1. And also, we are going to pick this part that we have here, and we equate it to 2 sine x. Yeah. And if you cancel sine x and sine x, we end up having r sine alpha plus 2. So is equals to 2. Then if you want to find alpha, you are going to divide equation 2 by equation 1. So that you can see, once you divide, r will cancel out. You remain having sine alpha over cos alpha, which is the same as tan alpha is equals to 2. So meaning that if you want to find the value of alpha, you are going to find the arctan, or the tan inverse of this particular equation that we have. And if you work it out in radians, you are going to get your answer being 1.107. For you to find the value of r, you are going to square equation 1 and equation 2, and then you add them together. So if you square them, you are going to have r squared cos squared alpha equals to 1, and r squared sine squared alpha is equals to 4. Because this was 2 here, so you square both sides, you are going to get that. And then if you add the two equations, you are going to get they are equals to 5. So you factor r out, but remember now this part that we are having here is going to reduce to 1, because cos squared theta plus sine squared theta is basically equals to 1. So once you have gotten that, you can see you are going to remain with r squared is equals to 5. Then if you find now square root both sides, r is equals to root 5, and basically you're gonna have your answer there. Now the next part is use answer in A. Write down the exact maximum of exact maximum of g of x. Exact maximum is going to be, remember when we are talking about maximum, and maximum of g of x is obtained from f of 2x. F of x was this. So the maximum value of f of x, the maximum value is root 5. So since it's 7f of x, now the maximum value of 7f of x is going to be 7 root. You just multiply this number with the maximum value of this. So that's going to be 7 root 5. That's the maximum of 7f of 2x. Because this number we have here 2 does not affect the maximum and the minimum value. Then now, since it's addition, this can be subtracted and added. So the maximum value, we're going to add that. So it's going to be this value. And find the smallest possible value for x. You shall just take 2x minus whatever we were having here, 2x minus this. You equate it to pi. Yeah, because it's going to be 0 at pi. Then you solve for x basically, and then you're going to get your answer as 2.12. In question number 3, we are talking about matters differentiation and matters quotient rule, and how you do use quotient rule for you to answer questions. And you can see here we are told that function f is defined by f of x is equals to 5x minus 3 over x minus 4, where x is greater than 4. And then we are told, show by using calculus that f of x is a decreasing function. Remember, a decreasing function, which you did in P2, is a function that is always negative. A function is decreasing if it's less than 0. Whereby that means is if it's a negative. We can also say a function is decreasing if it's always negative. But if a function is always positive, then we can be able to say the function is increasing. So the main concept that you are doing here is to differentiate and check the derivative of f of x. Is it always negative? Then from there we can be able to confirm and say the function is decreasing. So at this point of time, I just need to make you understand that whenever you have this kind of expression as a fraction, for you to differentiate, you are going to use quotient rule. And under quotient rule, we are going to assign the top number u, and the top term, the bottom term, we assign it as v. So which means that using quotient rule, v du dx minus u dv dx. So for you to prepare this expression that we have here, I want you to identify what's your u and what is your v. Once you have done that, go ahead, differentiate each of them so that you have ready du dx and you have dv dx ready for you to substitute it into the equation. Guys, make sure always when you are answering questions in exams, you are organized, your work is neat, so that the examiner can be able to see all the steps that you are writing down. Then once you've done the substitution, you can see now our function is going to become f prime x is equals to negative 17 over x minus 4 raised to power 2. So something that we need to appreciate, guys, here is that this function, the denominator is always positive because it's squared. It's always positive. The denominator is always, it's forever positive. But now the numerator is always negative. So meaning the function definitely is going to be in such a way that is going to be always less than 0. So f of x is basically a beautiful decreasing function. Is the decreasing function by show of the fact that is always negative. The next question that you may be asked is to find the inverse of a function. And for you to find the inverse of a function, you really need to remember that inverse of a function is going to be obtained if a function is a one-to-one function. So that one you should have put it in mind, that a function will have inverse only if it's a one-to-one function. Now in this case, we are given f of x is equal to 5x minus 3 over x minus 4. Now first thing first, you are going at this point to convert or to change f of x, you change it to y. Once you have changed that, then you are going to switch x and y, meaning that where you have x, you write y, and where you have y, you write x. And that is exactly what I've done here to switch. Then the next business of the day you'll have here is to make y the subject. And once you've made y the subject, guys, you have your inverse of that particular function. And don't forget to mention the domain, and the domain to this function is going to be x is greater 5. Show that f of x. Now this is a concept to do with composite functions. Now we are in composite functions, whereby you are told that show that f of x is equals to x plus c, where a, b, and c are constants to be found. And since we understand that f of x is this, it means that we are going to replace anywhere you have x in this function, anywhere you have x in this function, you are going to replace the same function. That is exactly what we are doing here. You can see I've replaced this guy here, and I've replaced this guy here also. Yeah, because here we were having 5x, so I have replaced 5x minus 3 over x minus 4. And where we are having x down here, I've replaced 5x minus 3 over x minus 4. Then now you need to go ahead to simplify the expression. And the way I decided that I'm going to simplify this, I've taken the numerator and denominator by times x minus 4 so that I get rid of the fraction. I don't feel good when I see fractions. I have to remove that fraction basically by multiplying at the denominator and at the numerator by that fraction, which is x minus 4. So you can see, if you multiply the numerator by x minus 4 and you multiply the denominator by x minus 4, guys, again, don't go ahead and cancel this, that now you go and cancel this value and this. What have you done? The reason is why we multiplied, we want to get rid of that. So if you take now, for instance here, guys, if you take this term, multiply to the first term, and also you take this term, multiply it, this term to this, and also you multiply this term to this, you can see now x minus 4 will cancel out. Similar to the denominator, x minus 4 will cancel out. And if you faithfully simplify this expression, ensuring that you follow all the steps properly, you are going to have 22x minus 3 over x plus 13, which is basically the expression that we are being asked in this question. So that is basically what you are going to do in that part. Question 4, you really need to have a strong understanding on how to perform integration of trigonometric functions, integration of rational functions like these ones, integration of basic functions. So for fractions, and especially rational functions like this one, remember we are going now to introduce natural log. And what we are going to do, because this equation that we have here, here we are having 9, what I'll do, I'll take the 9 out. Then I can see that if I differentiate this part, I'm going to have 6x. So I'll ensure that I'm going to introduce here, you can see I'm not having 6. First I took the 9 out so that I can see what to introduce. So if then I look at, if I differentiate this part, I'm going to have 6x. So I must have also a 6x at the top. That's why you can be able to see it here, right? Now, since this 6x was not there, I've introduced it, I have to put it outside there, so that if I bring it in, it's going to cancel this and that. Now, once you have an expression like this, you are going now to say that integration is the same as ln of 3x squared plus k, then plus c. You introduce a constant c. So first step, take out any number that is there, you take it out, then you differentiate, you see what that should be, then you can see 6x, then you introduce a 6. And once you have introduced a 6 up, you have to divide and introduce a 6 so that it's going to cancel here and there. Don't want to repeat that. So now, given also that the integral of this is equals to ln of 8, because already we have done that particular integration, so basically what we're going to do is the introduction of the limits. And if you substitute the limits here, we'll end up having 3 over 2, because you are going to substitute 5 anywhere you have x, then subtract and introduce 2 anywhere you have x in this expression. So that if you subtract, something that we really ought to remember, let's factor out these 2, so that we are going to have 3 over 2 into ln of, and since this is subtracted, you can be able to divide those 2 and you express as a fraction. Now, since we are having 3/2. I think I should have yeah, this is going to be, this is 3/2. So if I want to bring it on this other side, it will be 2. Yeah, I have to change that. It will be, I think this is misbehaving. This should be 2/3. 2/3, yeah. So it should be 2/3, because if you multiply by, or you divide 3/2 both sides, it's going to flip. And once you do that, that's the same as 8 raised to power a third squared, and this becomes the answer. And if you solve for k, you're going to get k is equals to 9. Maybe if you have any questions regarding this, you can just write in the comment section, because once I'm going to read through the comment below, I'll be able to see and respond to any of their queries. Okay, so k translates to be 9. Then we need to look at question 5 and get to see what was being addressed in question 9. But see, if we are talking about a point and a curve, then it can be something to do with differentiation, and then we have tangent. And then you can see now, if it's a tangent, then the gradient of the curve is equal to the gradient of the tangent, something like that. But let's see that what is being asked in this question. The sketch shows the sketch of this. Oh, quite interesting. So meaning that this can be written as 3 plus 4e is to x squared raised to power a half, because of the square root. And then we are supposed to find the y dx. And this is the point where you are going to use chain rule, guys. Now, what I want you to do before you do anything in this particular question, the most important thing that you have to put into consideration, let's assume everything that is inside the bracket. So let's assume everything that is inside the bracket. Assume that is a single term where you are going to use differentiation by power rules. So you are going to take the power down, then decrease the power by 1. No more differentiation. So that's how you work out this question that require you to use chain rule. Just forget what's inside the bracket first, deal with the power, bring it down, then decrease the power by 1, and then write the what's inside the bracket the way it was. Now, once you have done that, you multiply the answer you have gotten times the differentiation of whatever that is inside the bracket. Remember, the first step or the first stage is don't look inside the bracket, assume whatever that is inside the bracket, differentiate normally by bringing the power down. Then write the expression the way it was, and then times the differentiation of whatever that is inside the bracket. And that's why you can see whenever you are differentiating 3, it will be 0. 4e is to that. You look at the power. Now, if you differentiate this particular power that we have here, if you differentiate this power, you are going to have 2x. So that 2x times 4 is going to give us 8x. E is to x squared. Don't forget, you have to leave the power of the exponent the way it was. Guys, don't make a mistake again not following what I'm telling you, because these concepts you have to take them seriously. Don't make mistakes. Now, basically, this is what we're going to have, because a half times 8, that's going to be 4x, and then our expression is going to remain that way in simplified form. Question to do with proof is areas you really have to look at. Under trigonometric identities, you can be able to use these trigonometric identities that are here for you to do the proof of that. Just check a link in the description. I've added a link to the marking scheme, how you work out that. let's look at also modulus functions. So in question to do with modulus functions, a few things that you really ought to remember is how to find the vertex. So if you're given a general equation like this, and then you are supposed to find the vertex, a modulus bx minus c plus d. For you to find the vertex, and remember the vertex is the coordinate of this point P here, you just look at the equation and the x coordinate will be the term here, and if it's a negative it will become a positive. If it's a positive, you write the x coordinate to be negative if it's a positive, but if it's a negative you take positive c over b. Then the y coordinate will be the value that is added or subtracted. So which means that if there was nothing added or subtracted, the y coordinate will be 0. Okay, so what am I saying? If you are having y this software is really messing me up when I'm trying to write, guys, but let us just use this example that we're having here, because the pen is refusing to write. So now for instance here we are having kx minus 10, so the vertex is going to be 10 over k. Because this is a minus, we are going to take 10 over k, then whatever is added is k, also we write k. So that's why I'm saying that if this is negative c, it will be c over b, plus, and then the y coordinate of that vertex is going to be d. But also if you are finding the intercept, x-intercept or the y-intercept, at the y-intercept x is equals to 0, at the y-intercept x is 0. So if you substitute x is 0 here, we are going to have modulus of 0 minus 10, which is the same as modulus of negative 10. And modulus of negative 10 is 10, because modulus means if it's a negative, you take it positive. So that's why you can see we are having now 10 plus k, but the x coordinate is going to be what? 0. Because we are being asked the coordinate of the vertex point and the coordinate of a, whereby the coordinate of a is actually the y-intercept. So at the y-intercept, x is 0. And the vertex, you are going to use this formula I've written here, guys, so that anytime you're going to be asked questions like that, you'll be in a position to answer that. Don't get a question wrong by not getting the logic behind answering that question. I know some students make a mistake, they're gonna take negative c. No, it should be positive c, meaning that if it's a negative here, you take positive. If it's a positive, you take negative. Find in terms of k the range of values of x for which this modulus is greater than 2k. And in this question, I've tried to do in two methods, so that you can be able to choose the easiest method for you. The one that you love, use that. The one that you find is easier, use it. Don't go ahead in an exam to try to use a method that is not easier for you. Don't show an examiner how powerful you are by using a particular formula. Use a formula that is the formula that you understand. Yeah, so every time you're given a question in an exam, make sure you use a formula that you understand in that particular case. So we need to now see how are you going to approach this. So since the modulus is that, you can be able to take whatever that is inside the modulus is positive. So we're going to say k x minus 10 plus k is greater than or equals to 2k. So we're going to put those terms with x. We are going to make x the subject in this case. So you can see if I take this k on the other side, it becomes 2k minus k, that becomes k, and 10 becomes positive, and ideally our x is going to be greater than or equals to 10 plus k over k. Now if whatever that was in a modulus is negative, then we are going to have negative kx minus 10 plus k is greater than or equals to 2k. So also this, you can see if you expand the negative, you distribute it inside whatever we have here, is going to reduce to what? Is going to reduce to x is less than or equal, because if you divide a negative both sides, you can see here, if you are going to divide by negative k, this sign is going to flip and it becomes x is less than or equals to that. So that's one. Then the two answers are this and that for x. Range of values of different value of x. Another way you can be able to look at it, or the second alternative method, is you take this k on the other side, you simplify the expression, you remain with modulus kx minus 10 is greater than or equals to x to k. Then you square both sides so that you get rid of the modulus. If you want to get rid of the modulus, you are going to square that. So if you square, then you are going to have a quadratic equation whereby we shall have our a is k squared, our b is negative 20k, and our c is 100 minus k squared. Now if you put that inside a quadratic equation, you are going to have two answers like that. And now since the equation, the inequality was pointing greater than, then it means we need greater than 0. Greater than 0 will be above this line here. So that's why you can see our solution will be toward this direction and also towards that direction, and that becomes also the answer. So depending on the method that is easier for you to answer questions here, make sure you use it, the easiest method. Now we are talking of a modulus function. So given that the line with the equation y is equals to 3x plus 1 intersect the graph in two distinct points, so meaning it has to intersect in two distinct points. Yeah, and from here you can see with this particular equation that we are having here, the gradient is 3x. So the slope should be in such a way that k must be greater than 3. Because if k is less than 3 or equals to 3, this line is going to be parallel to this one. And that is going to bring problems. So one of the conditions we are going to say is that k must be greater than 3. Must be greater than 3 at that given point. So that's, once you've done that, the other way to approach it also, how you proceed from here, is now equating the two equations. So equating the two equations, we are going to have x is equals to kx minus 10 plus k is equals to 3x. Basically, we are just taking the modulus function that we are having, you equate it to the 3x plus 1. If you work it out, you're going to get x is equals to 11 minus k over x minus 3. And because it's a modulus, there is another option is when whatever that is inside here is a negative, also you equate to the same part. You are going to have two values of x. And what are you going to do with these two values of x? You are going to equate the two values of x so that you can be able to form a quadratic equation which you shall solve. Because this x and this x must be what? Must be equal. Then now if you equate them and then you solve that, you are going to have our k is equals to -5 all 6. Now we are going to understand that k is a positive what? Constant. So there is no way we are going to accept a negative value of k that we are having here. So we shall ignore this. And therefore, since we said k must be greater than 3, and then k must be less than 6, and now that becomes the range of values of k for that. Question number 7 is a question to do with trigonometry. Under trigonometry, you may be told to show that the equation this can be written in this particular format. And in this case, we are using trigonometric identities. You have to understand how to use trigonometric identities here. Now, anytime you are doing question to do with trigonometric identities, try to see which is the most appropriate trigonometric identity. Here we are having sine. So we are going to check the one that has an angle theta minus 30. So it will be a minus b. So which means that this equation can be written as sine a cos b minus cos a sine b. This can be written as 2 into sine theta cos 30 minus cos theta sine 30. So, but cos 30 is the same as root 3 over 2, and sine 30 is the same as a half. So meaning that this expression that we are having is going to reduce to what? Root 3, because root 3 over 2 times 2 is going, 2 will cancel out. So we shall have root 3 sine theta minus cos theta is equals to 5 cos theta. Now, if you divide by cos both sides and then you divide by root 3 both sides, you're gonna have these two cancelling out, and then we have 6 over root 3, but sine theta over cos theta is basically that tan theta. And then if you rationalize the denominator on this part, we are going to have this reducing to 2 root 3, because root 3 times root 3 will give you 3, and then 6 divided by 3 will give us 2, times root 3 will give us that. So make sure before you sit for your paper, you have an idea how you use. Before you sit for that exam, you must be able to know how you use these trigonometric identities. Now, in the process of using this equation that we have worked at the top, then next they are telling you hence or otherwise solve this. So you can see that whatever equation that we have here is the same equation that is similar to the equation that we were having here. So what I just did, I took tan, I say that everything that we have here can be written as tan theta is equals to 2 root 3. I solved for theta and I got my theta to be 73.9 as the first angle. The second angle will be the angle in the third quadrant, because if this is 73.9, this angle also is going to be 73.9. But since we are working where tan is positive, then it means tan is positive in the first quadrant and in the third quadrant. Then for me to get this angle, the red one, it will be 180 plus 73.9, which translated to 253. But since this was plus, you can see it's x plus 20. But here it was just theta, or it was just x. Then I have to subtract that 20 that was added there, that has been added here. So to get the solution for x, So it will be 73.9 minus 20, 253 minus 20, and this becomes the answer in that case. So basically that's what you gonna do when you are given such a question. Now, linearizing nonlinear equations is also another area that you have to ensure that you have an idea on how to work it out. So since it was log t base 6 was plotted against log x base 6, a straight line will be log t is equals to m log x base 6 plus c. And the reason as to why I'm saying that is because this is a straight line. It has to be in the form y is equals to mx plus c. So this equation is a straight line. It can be written in the form y is equals to y equals to mx plus c. Now our y is log, because you can see here our y is having this value here and our x is having that value here. That's why I've replaced them in this equation. M is the gradient, so we can be able to use these 2 points to find the gradient of that line, and the gradient is going to be -2, and the y-intercept is c, which we can see here it's actually 4. Then if we are to write that equation, it becomes log t base 6 is equals to -2, because it's the gradient, it takes the space of m, and we say plus 4. Hence find the exact value of t when x is 216. So we are going to substitute where we have x, we write 216 in this equation that we have gotten here. That's exactly what I did at this point. Now, because they want exact value, I said I'm going to raise this 2 to the number that was inside the log. So it will be log t plus log 216 squared. But when 2 logs are added, you can multiply the numbers. So that that means that this number that you have here and this number can be multiplied so that you can be able to have a single log. So those are the basic rules of logarithms. And then we shall now express it index notation. So we're going to say 6 is the base raised to power 4 is equals to whatever that we have here. So we shall have 216 squared t is equals to 6 raised to power 4. Then you divide by 216 squared, then the final answer for t is going to reduce to what? 1/36. 1/36 is the answer. And hence find the equation not involving logs linking t and x. So basically we are going to write the expression the way it is initially. Then we shall say, now this is okay, this is we shall take the all of this expression to the other side. We shall have log t plus log x squared. Now if you're having this, we can be able to reduce it to a single log, and whenever you are reducing to a single log, you are going to multiply the values or the variables that are there inside the logs. This one and this one are going to be multiplied. That's why now we can see we are having x squared t. Yeah, x squared t. So with that, we shall say it's equals to 4. And to remove the log, we are going to convert that to index notation. Because this is base 6, so we are going to say x squared t is equals to 6 power 4. Base 6 raised to the power, and then we divide by x squared both sides. We shall have our beautiful equation becoming 1296 over x squared. Last but not least, we have a question also to do with the differentiation, but now a little bit different approach. And I think that is going to mark the end of our question. You can see we are given x equals to y, e is to 2y. x in terms of y, and then you are supposed to show that dy dx is equals to y over x into 1 plus 2y. So in this case, the first thing that I want you to appreciate here is the fact that this equation that we are having here involve a product of two functions, y and e is to 2y. So meaning that we are going to make use of product rule. In that way, you have to remember that product rule is given by u dv dx plus v du dx. So the first thing you want to do, identify which function is going to be your u and which function is going to be your v. Then differentiate each of them. So differentiating y, you get 1. Differentiating e is to 2y is going to be 2e is to y, because you differentiate the power, you get 2, you multiply it to the function the way it is, so you get 2 is to 2y. Then once you've done that, we are going to substitute it into this part of the formula, and our it's dx dy is going to be 2y plus 1 e is to 2y. Because you see, if you factor e is to 2y out, basically that's what you're going to have. And if you look at this, e is to 2y is going to be given by x over y. So meaning that where you have e is to 2y, you can replace with x over y. At this point, we can replace it to x over y. That's what I did. And x over y now can be written as that, yeah, dy dx will be x into 1 plus 2y over y. And but the question was asking us to find what? Dy dx, but here what we have is dx dy. So at that point, what you really ought also to remember is that dy dx is the same as 1 over dx dy, then meaning that we are going to find the reciprocal of dx dy to get our answer, and we got our answer like that. Yeah, so that's what you're supposed to do, questions like that. And given that the straight line with the equation x equals to k, where k is a constant, cuts the curve at two distinct points. We are talking of this curve C. So we want, there is an equation x equals to k. So x is equals to k is going to cut the graph at two distinct points. Okay. Yeah, so my graph and my k, or my graph, I've just shown it here. This is the line. When if it's cutting x at two distinct points, then it must be within this region. Because if you shift this graph, look at this. If you shift this graph this way, at this point it will be cutting 1 point. If you shift the graph at this point here, it will be a tangent to the curve. So meaning the graph, the line should cut the graph somewhere there. So you can see also that this graph has a turning point at this point. This is the turning point of the graph. So if you know the turning point, and then we know this is x, then our k should lie between the value of the turning point. It will be oscillating. K can lie anywhere there. So that's why you can see what I basically did in this question is working out dx dy equals to 0. At the turning point, dx dy should be equals to 0. So I could take dx dy that I had gotten here, I equate it to 0. You see this one? Dx dy, I equate to 0, because if this is a function and this is the turning point, then this dx dy is equals to 0. So that's why you can see I'm having 2y plus 1 e is to 2y. So meaning that this part is equals to 0, or this part also is equals to 0. But there is no way an exponent can be equals to 0. So this one died on arrival. We remained with one value, y, 2y plus 1 is equals to 0, then if you take 1 on this side, you're gonna have y is equals to negative a half, as the y value at this point is negative a half. If you want to find the x value, you are going to substitute y is equals to negative a half into the original equation. The original equation, guys, was this equation that we were having here. This is the original equation. So if you substitute y is equals to negative a half, you will know what the value of x is, and that is exactly what we are interested with. We are interested with the value of x. Now, meaning that our x is going to lie, is our x at this point x here, where the turning point is negative e is to negative 1 over 2e. Then meaning k should lie between these values. Then you can see now k should be less than 0 but greater than negative 1 over 2e. Yeah, so that is those are the main areas you really ought to be ready to prepare, so that when the exam is going to be asked, guys, you'll be in a position to answer those questions. And if you have gotten value from this video, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. And guys, if at all you've gotten value from ProfLearn YouTube channel, I ask you to recommend this video to somebody who can also benefit from the same. Don't forget to leave a comment whether the video was helpful to you, something new that you've learned, so that I can be able to know that whatever that content that I'm putting out, it's helping out somebody out there. See you guys. See you in the next video. See you in the next tutorial. Don't forget to subscribe, like, and also share to all your classmates and friends. See you guys.